Today's lesson is on binomial probability with experiments. So binomial probability is used to find probabilities when there are two possible outcomes. And there's actually two keywords to look for when to use this technique. So the word exactly or the word only help clue you into using this formula we're about to learn. So the formula is you take the total trials and you choose your successes, and then you times it by the probability of success, and you raise that to the number of successes, and then you times that by the probability of failure and the number of failures. So let's do an example, and it'll make more sense. At any time you can pause this video if I'm going too fast and you need to catch up on taking notes. So suppose there were 6 total trials and the probability of success was 30%. What is the probability of exactly 4 successes? So the formula says to start with total trials. Well, there are 6 total trials. Choose the number of successes. Well, there are 4 successes. So 6C4 is the beginning of your formula. Then in parentheses, you're going to put the probability of success. The probability of success in this problem is 30%, which is 0.30. And you're going to raise that to the power of the number of successes. So once again, that's 4. So you'll see that these two numbers match. And then you're going to multiply that by the probability of failure. Well, they don't explicitly tell you what the probability of failure is, but if the probability of success is 30%, then the probability of failure is 70%, because those have to add up to 100. So those always have to add up to 100%. Okay. All right, so then we also need the number of failures, goes up here for its power. If there's 4 successes and I'm doing it 6 total times, that means there's 2 times left over for failures. So these two numbers will add to the total trials. Okay. All right, here's a word problem. If a family has 4 children, what is the probability that they will have exactly 3 boys? Well, in this problem, we're going to say a success is having a boy. That's a success. Well, how many total children are they having? 4. Choose how many successes. Well, that's how many boys, so 3 boys. In parentheses is the probability of success. So what's the probability of having a boy? 1/2 or 0.50. Either one works. Then you raise that to the power of how many successes you want. Well, you want 3 boys or 3 successes in this problem. Then the next parenthesis is the probability of failure. Well, if a success is having a boy, then in this case failure is having a girl. And the probability of that is also 1/2. And if you're having 4 children, you're going to have 1 girl left. So you type all that in your calculator. 4 choose 2 times 1/2 to the third times 1/2 to the first. And for this one, you get 25%. All right, number 2, suppose that a coin is tossed 5 times. What is the probability of getting exactly 2 heads? So in this case, a success is a head showing up on the coin, okay? And let me go back. I should be underlining the keyword exactly on both of these. Okay, in number 2, how many times are you tossing the coin? 5 total times. Choose how many successes do you want? How many times do you want to get ahead? 2. Then in parentheses, what is the probability of getting ahead? Again, 1/2, because you could either get heads or tails. And how many heads do you want? 2. So it's to that power. All right, what's the opposite of tossing a coin and getting ahead? It's getting tails. Well, what's the probability of getting tails? Also 1/2. So if you're tossing it 5 times and you get 2 heads, how many tails would you get? You would get 3. All right, so you type that in your calculator. 5 choose 2 times 1/2 to the second times 1/2 to the third, and you get 31.3%. All right, number 3, a die is rolled 3 times. What is the probability of getting exactly 3 5s? So exactly is the key word telling you to use this formula we're using today. A success is a 5 on the die. Okay. All right, so how many times are we rolling a die? Well, we're rolling it 3 times, but we also want to get 3 5s. So this one's 3C3. All right. What is the probability of getting a 5 on a die? 1 out of 6, because there's one side that has a 5 on it. And how many 5s do we want to get? 3. Now, be careful here. What's the probability of not getting a 5? That means I could get a 1, 2, 3, 4, or 6. So that is 5 choices out of 6. Now, if I'm rolling it 3 times and I want to get 3 5s, how many times do I not want to get a 5? 0. Anything to the 0 power is 1, so it disappears in this question. So in your calculator, you would do 3C3 times 1/6 to the 3rd power, and that gives you 0.46% or 0.5%, however you want to write it down. Number 4, Taryn and Sam are playing a certain board game. The probability of Taryn winning a game is 75%. If they play 5 games, what is the probability that Sam will win exactly 3 games? So exactly is our keyword. What is a success in this one? Well, in this case, the success is that Sam wins. Well, how many total times are they playing? They're playing 5 games. And how many times do we want Sam to win? 3 games. Okay, once again, you really need to read carefully. What's the probability that Sam wins? Well, 75% is Taryn winning. So for Sam to win, that would be 25% because they have to add up to 100. And we want him to win 3 times. So the probability of Sam not winning would be 75 because that means Taryn wins. And how many games will Taryn win? 2 because there's 5 total games. All right, once again, you type that in your calculator and you get 8.8%. Feel free to pause this at any time if I'm going too fast. All right, suppose that when hockey star Jamari Jones takes a shot, he has a 1 out of 7 probability of scoring a goal. He takes 6 shots in a game one night. What is the probability that he will score exactly 1 goal? So keyword is exactly. Let's figure out what a success is. So a success is scoring a goal in this question. So how many total shots does he take? He takes 6. And how many times do we want him to score a goal? Once. Okay, what's the probability of him scoring a goal? Well, they tell you it's 1 out of 7, and we want him to make 1 goal. Now, if the probability of him making a shot is 1 out of 7, what's the probability of him missing? That would be 6 out of 7. It's the leftover. So if he's taken 6 shots and he makes 1, that means he misses 5 of them. So you type that in your calculator and you get 39.7%. Okay. All right, number 6. One section of Mr. McDonald's history test has 8 true-false questions. What's the probability of getting 0 correct? So a success in this one is getting it correct. How many total questions are there? There are 8. And how many do I want to get correct? 0. Well, what's the probability of getting a question correct if it's true, false? 50-50, so 0.5. And you want to get 0 of them correct. Well, what's the probability of getting it wrong? 0.5, because I have to add up to 100%. If you're getting 0 correct, that means you're getting 8 of them wrong. So type that in your calculator, and it's 0.4%, which is very small. All right, last question. In 2001, the American Heart Association reported that 50% of Americans who received heart transplants are ages 50 to 64, and 20% are 35 to 49. In a randomly selected group of 10 transplant recipients, what is the probability that 3 of them are ages 50 to 64? So, a success is that their age is 50 to 64. Well, how many total people are there? There's a group of 10. So 10C. How many do we want to be ages 50 to 64? 3 of them. Okay. Now you're going to have to read carefully. What's the percent of people who are ages 50 to 64? 50% are ages, are ages 50 to 64. So 50%. This 20% is just there to confuse you. You don't need it. Okay. So 50%, and we want 3 people to be in that category. So if 50% are ages 50 to 64, what percent is left over? Well, 50%. Add up to 100. All right, so you wanted 3 people to be ages 50 to 64. You have 10 of them, so that means 7 will not be in that category. And that gives you 11.7%.